Right, let's talk about this CFA business with the conservation of matter. So we want to be able to predict the relative number of atoms in the reactants versus the products and at the atomic molecular scale. And I want you to be able to calculate, right, the mass of any component of any given chemical reaction. All right, so that means the stuff that we're mixing, calculate what the amounts of one of those particles are. All right, so we have calcium chloride and sodium bicarbonate in this sample reaction. They mix together to make a precipitate called calcium carbonate, sodium chloride, water, and carbon dioxide. Calcium carbonate, that's stuff that gets hot. It's kind of exothermic, so it gives off heat or loses heat through the process of mixing. Sodium bicarbonate, baking soda, is endothermic. It kind of absorbs heat come on the inside at the molecular scale. Therefore, it feels cold on the outside. Very strange. It feels cold, but the molecules are gaining heat on the inside. All right. So, what is the gas that's produced in this chemical reaction? By memory, we should know way back then that carbon dioxide is a gas at room temperature. Okay. What is the precipitate? Calcium carbonate is insoluble in water. Less than the hundredth of a gram can dissolve in water well. So it's basically insoluble. All right, how many oxygen atoms are on the reactant side? The reactant side class is the left side. Let me highlight this. It's the left side of the reaction arrow. This is the reaction arrow. So on the left hand side is the reactants. On the right hand side, we call these the products, what's being produced. And this is French chemist in 1789. His name is Antoine Lavoisier. He died about maybe like 7 years later, 8 years later, but 5 years later. But anyway, he said Antoine Lavoisier, or Anton Lavoisier, French guy. They called him the modern father of chemistry, but other guys had that title as well. But he said matter is not created nor destroyed. So atoms just rearrange. So when you bake a cake, you put the eggs in there and the butter, the sugar, the milk, flour, and all that. Well, it's totally different from that batter, that mixture, or before you even made the batter, it's different stuff. It looks different, had different properties. When you add heat, they go chemical change. All right, chemical change is you add something sweet to eat. So it's the same thing. It didn't disappear. It just changed form. All the atoms, elements are still in place there. Okay, so let's go ahead and roll down to right here. What produced carbon dioxide? Well, these chemicals right here. These these chemicals, calcium chloride, sodium bicarbonate, they created all this stuff on the right hand side of the reaction arrow. Okay. And highlight this already. So what's the molar mass of water and calcium chloride? And these are the atomic weights. Okay. I don't have my drawing tools right now. I'm using Screencastify. For some reason they hating on me today. So if we look at water up here, I like to draw my stuff sometimes. So water, H2O. Each hydrogen has a mass of 1. Each oxygen has a mass of 16. I have 2 hydrogen. All right, so 2 times 1, which is its mass, is 2. And I add that to the 16 value for this oxygen, I get 18. This is the list right here. All right, hydrogen is 1, oxygen is 16. Add them together, I get 18. All right, same thing for calcium chloride. So calcium chloride chemical formula is CaCl2. Have 2 chlorine atoms attached to 1 calcium atom. It's this linear model right here that we see with the this is bronze and green. All right, so calcium is 40, and I have chlorine, 2 of those, 35. 35 times 2 is 70. 70 plus 40 is 110. The correct answer is A. That's how we calculate those things. Okay. Get your math skills up. All right, so that's my explanation. Watch the video a few times. Um, of course, calcium chloride and sodium bicarbonate produce all these products in the reaction. Okay, so most important part is to determine or to understand, to know that whatever I have on the left side of the reaction is supposed to be on the right side of the reaction. When we add these like little coefficients here, uh, it makes this whole chemical equation be what we call balance. All right, we want to balance those equations. So that means I need like 2 cups of baking soda and 1 cup of calcium chloride. Then I make 1 cup of this, 2 cups of that, 1 cup of this, and 1 cup of that. Okay, that's what it is. That's stoichiometry. It's a big word. Stoichion means substance. Metry means to measure. A little Greek terminology there. You learn a little something new every day, and that's what we have. So God bless.